Hey everybody, I wanted to go over this article just to maybe if it was difficult to understand or whatever, hopefully I can make it a little bit easier to understand. I know they extended the due date to the 29th, but I had read it last night before, and then today they extended it, thanks to Holly. So thank you, and I'll probably summarize it this week coming up or this weekend. But the main thing they're talking about is it says understanding correlation, factors that affect the size of the R. So the things that they talk about are going to be, the 6 factors are going to be the amount of variability in the data that will affect the correlation. You have the differences in the shapes of the two distributions that would also affect it. Lack of linearity. So if you have a curved line instead of a straight line, the presence of one or more outliers, characteristics of the sample, and measurement error. So the ones that I was able to recreate are going to be, I guess, the first 5. But I read the whole article and I really liked it, believe it or not. And it gives a lot of good information on why something would affect the correlation. So I ran some correlations here based on this article, and I can send this out to everybody. But this is the raw data. This is an Excel spreadsheet. This is the raw data that they gave us. We have the first one is a participant number. I should have put that on here. Participant number. This is just the raw data. I just recreated it here in Excel. And then we have X and Y1, X and Y2, X and Y3, and X and Y4. So this way I could run my analysis on it. So looking at this, I'm thinking I might be able to run the analysis that's required for our next assignment on Excel and not have to use SPSS. But I'll give you more on that later. But for now, this is just the raw data, and then nothing there. Okay, so then here is X and Y1. So just to give you a big view there, what I did was I ran a histogram of column X and a histogram of column Y1. So those are the ones we're going to be correlating. And if you look right here, we have 30 participants in each. And the histogram shows the following. So it shows that your amounts, your numbers, you have, and your frequencies. So you have 1, you have 4 2s, 10 3s, 10 4s, 4 5s, and you have 1 6. And so that's what you see in this first column here. You'll see that if you were to look at that, 1 6, 4 5s, etc. So that comes out here in the histogram chart that I created. So this is just the frequency chart, and it shows you have 1 1, you have 4 2s, 10 3s, etc. So you see that there. And it looks like you have a lot in the 3 and 4 range and smaller amounts out in the other areas. I ran a frequency then of Y1. They're the same set of numbers. They were just in different orders. So the frequencies are going to be identical if you look at the X and the Y1, but the way they were arranged, you'll see that they're different. See, if you have 1 and 2, this is the same, but then you have 2 and 1, 2 and 3. So some of them are the same and some of them aren't. So you're not going to get a perfect correlation, but you're going to get a very high correlation. And we see here, I ran correlation analysis through through Excel, and we get 0.83. And if you look at the article, that's the exact number that they gave for the correlation between X and Y1. Let's take a look. 83 right here. 0.83. So I know I was doing it correctly. That's a correlation. So you can see that these are very highly correlated, X and Y1. Now, what they did next in the article was that they changed the data. So they kept the data the same for y1, but they called it y2, and the thing that they changed was they got rid of the last, well, that's misspelled. This says removed. Removed. Okay. So they removed the last 5. So everything's the same from y1 to y2, except they removed the last 5 to give it some, to what we this is called range restriction, right? We're restricting the range to just show the top 25. So we look at the frequency. Of course, that's going to be the same for x because nothing changed with x. But then with y2, we're going to see what changed. We don't have any 5s in there anymore, or 6s, because we restricted the range to just 1 through 4. And you'll see it if you go through here, you'll only see 1 through 4. So do you think the correlation will go up or down? It went down to 0.71. So this is the correlation between x and y2 due to range restriction. Okay, so we had a little bit lower. So that's just showing, the article is showing you that, hey, when we restrict the range, it will affect, or it could affect, the correlation. And in here it did. Now we'll look at x and y3. With y3, we're taking the same data from y1, I think. Yeah, we are. We're taking the same data, but we're changing some of the numbers around. We're, instead of some of the 3s and 4s, we're making it very heavy on the 1s. Very heavy on the 1s. So that's going to provide skewness, right? If you look at the frequency of x, again, that stays the same. It stays the same on all of these because x hasn't changed. We're changing y. So now y3 has a whole lot of 1s in it, a little bit of 2s, a little bit of 3s, and it drops off. This is what we call positive skewness. We learned about that already. I think it was last semester. Positive skewness. So do you think this would decrease or increase our correlation? It decreases it to 0.68, so even further. This is the correlation between x and y3 with positive skewness in y3. Okay, so the next thing they showed us was, nonlinear. So this one's a little different. So y4 is the column we're looking at with this one versus, and in correlation with x, and x histogram stays the same, but the histogram on the y, or the y4, is different because that's the way the numbers ended up working out in column 4. Column 4 here. I couldn't really illustrate the non-curvature of this relationship like this, like I could with the other, like I could show the relationships in the other tabs here. So I'd have to do a scattergram. So anyway, I'll refer you back to the chart here. To the spread, the actual printout, and you can see, and I drew in somewhat of a curvy line. This represents x and y4. Okay, so it looks kind of curvy to me, and that would then increase or decrease the correlation. And as it says in the article, correlation is actually 0. There's no linear correlation. There's no correlation to this because we're looking at a non-linear set of data here, x and y4. So that's the non-linear example. So this article is just showing that different things that happen to your data, different changes they do affect the correlation. There was one more, and I have the last tab for that. If you notice, we added, or the article added, a 31st participant, and for x and for y1. So we took the original amount from y1, or the original numbers from y1, the data, and we added 10, and then we added a 9 on x. Really, those are, I would consider outliers, right? Because all the other numbers go from 1 to 5, 1 to 6. Here, 9 and 10 are very much outliers. So when we go and we do the frequency for x, we will see some changes here. You'll see that now we have an additional x value right here. That's 9. So the histogram looks a little different because now we add one more number in it. It's just slightly different. And then Y1 is the same, except instead of a 1 9, we have 1 10 in here. We have a 10. So by adding the 31st participant, we're going from, what is it, 0.83. You think it'll go up or down? Add in an outlier. It actually goes up to 0.91. So they're showing more correlation just because we added an outlier there. So not sure if that's really the thing to do. Maybe we should drop that outlier, because if it's changing the numbers from 0.83 to 0.91, it's not really adding value because it's an outlier. So that's something to think about on this one. So I'm gonna write my report pretty soon here and just kind of summarize everything here. But I wanted to at least bring it to you guys to look at, and hopefully my explanation, I'm just looking for other things that I might have thought about. Hopefully my explanation makes sense, that you can write your summary, 3 to 5 page summary. And that's it then. Talk to y'all later.